Let's see Newton's universal law of gravitation. We have seen Newton discovered the gravitational force. आणि न्यूटन theory of gravitation काय आहे? Theory of gravitation ही जगासमोर आणली. And he used Kepler's laws. He used the information from Galileo. He used the data from Tycho Brahe, and he derived an equation which still holds good, which is in line with universal law of gravitation. So what the theory of gravitation says, or what universal law of gravitation says? First, let us understand what is universal. Why it is saying universal? The reason is that this particular law, this theory of gravitation is applicable to every object in the universe. It's not like that only for the objects on earth. It is not only between moon and earth. It is all between sun, moon, all the planets and in other galaxies as well. So it's called as universal. Gravity is the property associated with mass of the object. Gravity हा शब्द कशाशी रिलेटेड आहे तर mass of the object. More the mass, more the gravity. So what the law says, it states that every object in the universe attracts every other object in the universe with a definite force. म्हणजे युनिवर्स मधला कोणताही ऑब्जेक्ट असू दे, लेट अस से प्लॅनेट्स, अर्थ, मून, मार्स, सॅटर्न, जुपिटर, सन, जे काय आपल्याला प्लॅनेट्स माहिती आहेत, ऑल द प्लॅनेट्स having mass apply a definite, हा important शब्द आहे, definite fixed known force on each other. So let us say this is a one mass m1 and there is another mass, this is m2. So they apply the force on each other. So m1 will apply force on m2 and the force कसा आहे, attracts the force आहे, कसा force आहे. So m1 will attract m2. So this is the force that m1 will apply on m2. m2 will attract m1. See, every other object in the universe, म्हणजे m1 will attract to m2, m2 will attract to m1. So this is the force between the two. So that is what is universal law of gravitation. Now define it. What Newton discovered, right? So this definite force, sometimes this force F is also called as Fg, gravitational force, or you can say simply F. Book for the F, will say F. This F is proportional to mass of the objects. म्हणजेच काय? This F is proportional to product of m1 and m2. This F is proportional to m1 and m2. More the mass, more the force. समजा दोन्ही मास जर मोठे असतील तर force between them, attraction the force or gravitation, it will be quite high. So the force of gravitation is directly proportional to product of the mass, m1 and m2, product of the mass. समजा if there is another product here, another mass here, this is m3, small mass. So this force between these two will be proportional to m1 and m2. m1 will apply force on m3, कारण every object attracts other objects in the universe. So M1 will attract M3, so there will be force like this one. M3 also will attract M1, and this force will be proportional to M1 into M3. I hope you are understanding. This depends upon M1 and M3. This force will depend upon M1 and M2. So more the masses, bigger the attractive force between them. So this is the first theory he has put up. Second theory he has put up, the force is inversely proportional to square of its distance between them. This force is inversely proportional to square of the distance, average distance. Let us say this is the distance between this. Okay. So this is inversely proportional to square. This is more important. This is more important. Square. Right? This force is, see, if you go away from each other, the force of attraction will be reduced. Of course, kami ho jana. If the objects are closer, then the force of attraction will be quite high. That is the meaning of this particular equation. So the force is, and this is called as the inverse square law. This is called as the inverse square law, and this is a famous law. It states that, so what the inverse square law states that the gravitational force is inversely proportional to the square of the distance between the planets, between the objects, So this is a famous inverse square law. Why did he write square? Why Newton did not write r cube? Newton ने 1 upon r का मतलब है, 1 upon r cube का मतलब है. Why only 1 upon r square? This is based on Kepler's third law. Kepler's third law gave him the inputs to derive to this particular conclusion. So this is a famous inverse square law. So what the Newton says that the force of attraction between any two objects is directly proportional to the mass of the objects. F is m1, m2, and inversely proportional to 1 upon r square. So naturally, if the mass is doubled, if m1 is doubled, this force will be doubled. m2 will be doubled, force will be doubled. Right? The m1 is double double. See, if the m1 becomes 2 times, the force also will become 2 times. m2 is double double. The force पण काय होणार? डबल होणार. आणि m1 m2 दोन्ही जर डबल झाले तर 2 into 2 force will be 4 times. Force will be 4 times. So if the mass is double, the force is double. 1 upon r square. If the distance between the two objects is doubled, समजा distance is double झालं, so this r will become 2 times mu r dash will become 2 times r, and 2 times r square, that is equal to 4r. So the force will reduce by 4 times. The force will reduce by 4 times because this is inversely proportional. If the distance increases, force is going to decrease, but square. So the distance between the two objects is increased 3 times, then the force will decrease by 9 times because it's squarely proportional. If the distance between two objects is brought closer half, gravitation so we can conclude, so force of gravitation is proportional to m1 m2 upon r square. m1 m2 upon m1 m2, and this is inversely proportional. 1 upon r square inversely proportional, directly proportional to m1. I can remove the proportionality sign by introducing a constant. So I can say F is equal to G into dot m1 m2 upon r square. So this is the famous equation of Newton's universal law of gravitation, and G is called as Newton's universal constant of gravitation. It is called as a Newton's universal constant of gravitation. So G is a constant. It is a constant in the universe. It does not mean that it's only applicable on Earth. It is applicable throughout the universe. And here G ची value जी आहे ती किती असणार आहे बघा. What is the value of G? So if, let us understand, if m1 is equal to 1 kg, mass is equal to 1 kg, m2 is equal to 1 kg, r is equal to 1 meter. What is r? R is the distance between the two objects. R is the distance between the two objects. Then force of gravitation, then F is equal to, I'll put this value here, G into m11, m21 upon distance 1 square. So I'll get F is equal to G. So I can write down the definition of G is like this way. If two objects of mass 1 kg are placed 1 meter apart, then the force of attraction between them is equal to G. If two objects m1 m2 1 kg, mass 1 kg are placed 1 meter apart, distance between them is 1 meter, then I will get F is equal to G. Manje, if you want to do an experiment, take 1 kg, two objects placed exactly at 1 meter, determine the force between them, find out the force between them, and that force will give you the value of G. Right? That will give the value of G. And here is G ची value आहे. He G ची value, that is equal to G is equal to 6.673 into 10 raised to minus 11 Newton meter square kg raised to minus 2. So this is the unit. We determine the unit. Newton meter square dash kg raised to minus 2. So how this unit has come, that we'll see. So G value 6.673 into 10 raised to minus 11. 10 raised to minus 11. 10 raised to minus 11 चा अर्थ समजून घ्या. 10 raised to minus 11, G is equal to 6.673 divided by 10 raised to 11. Divided by 10 raised to 11. आता 10 raised to 11 म्हणजे किती बघा? 6.673 10 to 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. एवढं डिवाइड करायला पाहिजे तेव्हा g ची व्हॅल्यू येणार. सो व्हॅल्यू ऑफ g इज व्हेरी व्हेरी स्मॉल. As a feel you there, feel, take a feel of this one. 10 to -1 is very, 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 very small. So naturally, the force between two objects, 1 kg mass, 1 meter apart, the force will be how much? The force will be equal to g. So this will be the force. So if the object is 1 meter, distance 1 meter, then F is equal to g. And g ची व्हॅल्यू किती आहे? 6.673 into 10 to -11. या दोघांची व्हॅल्यू इक्वल होणार आणि ही एवढी व्हॅल्यू आहे. म्हणजे जर फोर्स जर आपण जर म्हटला, so this is going to be the g. So g is equal to force. So this is equal to force. So force will be equal to 0.0 1 2 3 4 5 6 7 8 9 10 6.673 Newton. So it's almost negligible force. It is almost negligible force. So this is the first. So you can understand the force of gravity is a weak force. It is a weak force. हा force खूपच कमी आहे. Secondly, the unit. So unit we can find out. हे लिहून घ्या. हे pause करा video लिहून घ्या. Unit we can determine very well. Force is in Newton, g. Mass is in kg. This is in kg divided by distance in meter square. हे सगळे या साइडला घेऊ. So g चं युनिट होणार Newton dash इकडे आला हा मीटर स्क्वेअर. This is a kg square. If I take kg here, so this is equal to g into kg square divided by meter square. Kg will come to denominator. That means kg raised to -2. Or I will write down like this way. Divided by kg square, correct? And denominator I can bring it to numerator. Newton meter square dash kg raised to -2, so -2. So this is the unit of g. So this is important unit तुम्हाला माहित पाहिजे. आता ही जी व्हॅल्यू जी न्यूटनने जी त्यावेळी मांडली 17th century मध्ये, ही व्हॅल्यू त्यानं मॅथमॅटिकली डिराइव्ह केली. पण there was one scientist, his name was Henry Cavendish. ह्या हेनरी कॅव्हेंडिशनं एक लॅबोरेटरी मध्ये सेटअप तयार केला. That experiment you are going to see in 11th and 12th. But हेनरी कॅव्हेंडिशनं एक लॅबोरेटरी मध्ये एक एक्सपेरिमेंटल सेटअप उभा केला. And he calculated the value of force, and from the force he derived the value of g. So Henry Cavendish experimentally proved this value of g. So you can imagine न्यूटनचे किती परफेक्शन जो मॅथमॅटिक्स मध्ये की त्यानंतर बऱ्याच वर्षानंतर दुसऱ्या सायंटिस्टने ते मॅथमॅटिकली प्रूव्ह केलं. So this is a little bit, summary of the Newton's universal law of gravitation. Formula F g into m1 upon r square. Very important formula. Force is proportional to mass of the objects, inversely proportional to square of the distance between them. आता याच्या आपण काही फोर्सच्या काही प्रॉपर्टीज आपण शिकणार आहोत. force on M1. So this both will apply force on each other like this, and this force is equal to G M1 M2 upon R square. This is the force. So it's the equal and opposite force. This is an equal and opposite force by each other. So this is according to Newton's third law of motion. Every action there is a reaction. So it's an action-reaction pair. Suppose now हे दोन planets आहेत M1 M2 आणि अचानक with some revolution आता हे समजा this is sun, this is the earth, this is sun, this is earth, and suppose the moon comes in between M3. Whether the moon comes in between, what will happen? Whether M1 M2 force will change, whether the force between F, I'll say 1 2, between 1 2 is equal to G M1 M2 upon R1 square. R1 2 म्हणतो मी याला. This distance I'll say R1 2. Distance between 1 and 2. I'll say this is a R, this is a 2 and 3. This I will say R1 and 3. Right? This is a force 1 2. This is a force 1 2. You can understand. या दोन्ही मध्ये अंतर 1 and 2. Mass 1 and 2 मध्ये अंतर 1 2. Mass 1 and 3 मध्ये distance 1 3. Mass 2 and 3 मध्ये distance 2 3. जर हा दुसरा मास जर दोन्हीच्या मध्ये आला तर या M1 आणि M2 च्या फोर्स मध्ये कमी येईल का? तुम्हाला वाटणार कमी येईल कारण मध्ये काहीतरी रिस्ट्रिक्शन आलं. समजा एक भिंत आहे, इकडे आपण लाईट मारला तर भिंत पलीकडे लाईट जाणार का? नाही जाणार का? There is an obstruction. So you will feel that this will cause obstruction and the force will reduce, but there is no effect. समजून घ्या, there is no effect on this force. Whatever the intermediate medium may be. Of course, this will apply a force now. This will apply a force on this one. Force, this is a 1 3. This also will apply a force. This will apply a force here, F2 3. Right? So they will have force on each other, but there is no effect on the force M1 M2. So the first one we can write down, it does not depend on the medium between them. Medium or object काही आला तरी त्याला काही फरक पडत नाही. So this is the first one. Second, if the distance is very very long, whether the force will apply? Yes, the force will go on reducing, but there will be a force. That is why, see, you can imagine the sun is at a very long distance from Earth, but still Earth revolves around the sun. That means sun applies gravitational force of attraction on Earth. Because the size of the planets are huge. Mass of sun is very high. Earth mass पण मोठा आहे. Though the distance is large, it applies force. So this we can call second. It's a long range distance. It's a long range force. It's a long range force. It is not short range. Means जवळ असतानाच apply होणार, लांब असताना apply होणार नाही. It's not like that. It's a long range force. Third, we have seen the value of G. We have seen the value of G. We know G is equal to 6.673 into 10 raised to minus 11. So since the value of G is minus 11, naturally the force of attraction is very very small. Very very small. So this is the weakest force. So it's a weak force. So it's a weak, or you can say weakest force that exists in the universe. That exists in the universe. Our weakest force that exists in the universe. ह्याच्यापेक्षा इलेक्ट्रो इलेक्ट्रोस्टॅटिक फोर्स हा जास्त आहे, इलेक्ट्रोमॅग्नेटिक फोर्स हा खूप मोठा आहे. इलेक्ट्रोमॅग्नेटिक फोर्स इज व्हेरी व्हेरी लार्ज than this gravitational force. 10 to 37 times. That is not our scope of learning. But electrostatic force is very very large. Nuclear force is still very very strong. So this is the weakest force that exists in the universe. Now we'll see one more thing. See, the force between the planets is weak, but it's sufficient enough to make them revolve around each other. That is basically because of mass of the planets. The planets are very huge. So this is the planet. This is the planet. So they will apply a force of attraction. मग हा हेही मास आहे आणि हेही मास आहे. सो हा इकडे फोर्स लावेल असा का इकडे लावेल फोर्स का इकडे लावेल का इकडे लावेल कुठे लावेल फोर्स. What will be the direction of force? What will be the direction of इतकं मोठं आहे म्हणजे जर फोर्स लावला तर अर्थच्या एका बाजूला लावेल का सेकंड साइडला लावेल का सेंटरला लावेल. सो द फोर्स इज ऑलवेज टुवर्ड्स is called as the center of mass. Is called as center of mass. So this is a COM, center of mass. It is called as a COM. So center of mass. So the force is always directed between the center of mass. So this is the force. What is center of mass? Center of mass म्हणजे हे सगळं जे काही मोठं मास आहे that is concentrated at this particular point and that is called as the center of mass. For example, एक पेन घ्या, मी इथं धरलं तेव्हा खाली पडलं. Why? Here the mass is more, gravity has pulled down. समजा मी इथं धरलं तेव्हा खाली पडलं because this mass is more. But समजा if I hold it here, then it is perfectly balancing. Left hand side, right hand side, perfectly balancing. So this is, तर या सेंटरला काय असणार आहे का सेंटर ऑफ मास असणार. म्हणजे राईट हँड साइडचं मास, लेफ्ट हँड साइडचं मास, इट इज बॅलन्स्ड. So we can call that particular point as a center of mass. So center of mass, so that is another point 4. The force of the gravitational force is towards is between the center of mass of the objects. And what is center of mass? So you can write down what is the center of. So these are the 4 major properties of gravitational force. Pause करून तुम्ही लिहून घ्या. Pause करून लिहून घ्या. So we can write down definition of center of mass or just information center of mass. It is a point inside the object, inside or outside of the object, where the total mass is concentrated. Total mass is concentrated. So this is the definition. So center of mass can be inside or outside. तुम्ही थोडं असं you will get surprised. अरे ऑब्जेक्टच्या आतमध्ये असायला पाहिजे सेंटर ऑफ मास. बाहेर कसा असेल but it can be outside. I will give an example. This also you are going to learn in 11, center of mass, a major chapter for science. So suppose if you take a ring, so this is the center of mass for the ring. आता या रिंगचं मास कुठं आहे? शेडेड एरिया दाखवलाय. This is the highlighted area, this is the mass. But center of mass is at the center of the ring. So whole of this mass is acting at this particular point. So this can be outside, it can be inside. It can be outside or it can be inside. Where the total mass is supposed to be concentrated. Newton's square law तुम्हाला सांगितलेला आहे, that is derived from Kepler's law. So now we'll derive the equation, derive some equations to prove universe square law. So हे लिहून घ्या. We'll see uniform circular motion we have studied. We'll go a little more into it, and magnitude of centripetal force. We have seen that if an object or the mass m is revolving in a circular orbit with a constant speed v, right? If an object m is revolving in a circular motion with constant speed v, then there must be a force which will act towards the center, and that force is called as centripetal force. So we know that we can write down, if an object is rotating in circular motion with constant speed, constant or uniform speed, then there must be a centripetal force, there must be a force acting towards the center, called as centripetal force. So we know that if an object is rotating in a circular motion, right, then there must be a force acting at the center. There must be a force acting at the center, directed towards center. Otherwise, this cannot change direction. So we can write down V is equal to constant speed R is equal to radius of circular motion, and I don't want to simply F, right? And F is the centripetal force. And M is the mass. So the cause of the revolution is centripetal force. Now, the value of centripetal force, so F is given by mv square upon r. So this is the equation of centripetal force. So you can write down so in this case F is given as, so centripetal force F is equal to mv square upon r. Now v is the speed. We know what is the value of speed. Speed is equal to distance upon time. That is distance upon time. So, if it makes one revolution, what is the time required to complete one revolution? So, time required to complete one revolution, म्हणजे one cycle is equal to t, and that is nothing but period of revolution. आपण शिकलो बघा, period of revolution. To complete one revolution, हा इथून चालू झाला, फिरत 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 इथं आला. The time required to complete one cycle is called as time period and denoted by t. Denoted by t. And distance traveled in one complete revolution is equal to, let us say this is the radius is equal to r. This is radius is equal to r. Then when it completes one revolution, then it will complete one perimeter, or one, in case of circular motion it will be circumference, and that is equal to 2 pi r. That is equal to 2 pi r. बरोबर ना? एक सर्कल जर पूर्ण केलं तर how much distance it will travel? 2 pi r. How much distance travel? 2 pi r. So 2 pi r distance is traveled in time t. So we can write down. So it means 2 pi r distance is traveled in time t. So that will give speed v is equal to distance upon time, that is equal to 2 pi r upon t. This is the first equation, this is second equation. Right? So we can put the value of v into the first equation. So we'll put the value of v in the first equation. So putting value of v in equation 1, we get. So f is equal to m, which value is there? 2 pi r divided by t whole bracket square, mv square whole bracket square, and divided by r. So r as it is. So r is as it is. So this will become, so m upon r, 2 pi the square मुझे 4 pi square, r the square r square upon t the square t square. So this is equal to f. This is equation of the math. Right? I'll rub this one. I'll rub this one. So I multiply here by r in numerator and r in denominator. So I'll write down here multiplying by r to both numerator and denominator. We get r meaning numerator ला पण multiply करतो आणि denominator ला पण multiply करतो. So I will get f is equal to m upon r square, r में multiply करें r square होईल, into 4 pi r square ला r में multiply करें तो r cube होना, and divided by t square as it is. T square as it is. आता r cube upon t square काय आहे बघा? According to Kepler's third law, t square is proportional to r cube. म्हणजेच t square या साईडला घेतला तर r cube upon t square is equal to constant, because otherwise we can say square upon r cube is equal to k. Right? T square upon r cube is equal to k. ते हे आपण शिकलेला आधी. So याचं इन्व्हर्स जर आपण केलं तर r cube upon t is equal to 1 upon t. So this is according to Kepler's third law. R cube upon t is equal to 1 upon t. T square upon r cube is equal to k, constant of proportionality. Here the inverse केला, so r cube upon t is equal to 1 upon k, where k is a constant. K काय आहे? Constant. K is a constant. So this is the third equation. And this is the fourth equation. If we put this value, this is the third equation. This is the fourth equation. So putting value of r cube by t square in equation 3, we get r cube upon t square ची value कुठे put करूया या equation मध्ये. So what we'll get, f is equal to m upon r square into 4, this is 4 pi square, this is 4 pi square, and this is r cube upon that is equal to 1 upon k. So mass of the object is constant, 4 is a constant, pi square is constant, k is constant. So 4 pi square m upon k, I'll take on one side, and into 1 upon r square. Since 4 pi square m upon k is a constant. एखादा पर्टिक्युलर प्लॅनेटचं मास बदलणार नाहीये, त्याचा टाइम पिरियड देखील बदलणार नाहीये. So this is constant, is a constant. Hence this f is equal to, so hence is proportional to 1 upon r square. So f is proportional to 1 upon r square. So this is the proof. This is the, so Newton concluded its inverse square law. This is called as the inverse square law from Kepler's third law of planetary motion. So this is called as inverse square law. So with the help of Kepler's third law of planetary motion, Newton derived that the force of attraction or the centripetal force is inversely proportional with the square of the distance between the objects. So this is a very important derivation. This is in a book. Learn kara vyavasthit. Here the t is time period. R cube upon t square is 1 upon k. We know that speed is equal to distance upon time. त्याचा आपण इथं